Okay, this is a progress video for Android game synSpace Drone Runners, unreleased version 1.09. And this version integrates Grid World and Critter World. Just go into Critter World here. And we're now in so-called UFO mode, where we're high up in the air and just flying along. And you can tell from the mini map, we are the red player. We are this little thing here. And we're headed towards the center of the screen, center of the map, where there is a base. There it is. So now we'll stop. So down below us there is a base, and we can zoom in. So we're way up in the air, but we can still zoom in down below. And we can have a little tiny bit of motion if we want to. Oh, we're walking in the air. Okay, stop. All right, and now just to show this in a little more detail, I'm going to change the shader to wireframe. And you can see the three objects are a sphere, or the top half of the sphere, a cube, and a runway, which is a flat plane. And the idea is that each of the objects is infinitely tessellated. So as long as it's a small object, it's just two triangles per side of the cube. But as I get closer, or as it gets larger on the screen, it breaks down into more triangles. And I have variable rates of triangle increase so that spheres get more triangles faster. But then, like, that's probably a mistake. I probably don't need that high resolution sphere ever. And then I guess I still have some bugs there too. The distance to these triangles is not really all that different from the distance to those triangles, and the perceived size on screen should be the same size. So that's a little wrong. But if we don't zoom in too far, it makes a certain amount of sense. And then they are colored in color mode. So we see the cube and the sphere are painted this purple color, and the runway is actually a pattern of red and black squares. And I've got the sun going around the planet once a minute, and the light is reflected there, and all that's happening there is I've got an actual circle that the sun's going around, although I play a little game so that the night is a little shorter than the day. And then I have an angle from the ground to the, for each triangle I can have a surface normal for the triangle and an angle from the triangle to the sun, which is moving. And then just the dot product of those guys gives me a grayscale value. And so I wanted to talk about how the retessellating works and where spheres come from. So we move the interesting example out of the way. We switch to lecture mode. You can see from there to there. It's not too complicated. I basically need a list of triangles to draw. So you give me a primitive like a cube. And a cube is just 6 square surfaces. Front, back, right, left, top, bottom. And what I do is, for texturing purposes, I let you provide a material for each of the 6 surfaces. And probably usually you call out the same material for a lot of them, but I thought that would give me the most flexibility in the simplest system. So I basically have a function, render cube. Only you'll see later that it's not just cube, it's primitive. And but I always start with a cube, no matter what. If I'm going to do a sphere, I start with a cube. And then what happens is a cube is 6 faces, but it's 8 points. The 8 corner points. So if I'm drawing a cube, all I have to do is map the 4 points, then consider them to be 2 3-point triangles where the triangles share a couple of points. And then I just render this triangle and I render that triangle. Or in this case, I don't actually render it so much as I spit the triangle off into a list of triangles that I plan to draw. And then I do some analysis later of that list to pick the best triangles. And then I sort them most distance to closest, and then I cull them to the best n, because I have a triangle budget where n is fairly small, and then I render it, all the triangles at once. But what if I've zoomed in on this cube and it's really big, and now if this is the screen, the cube is now much bigger than the screen, so I can only see just this little part of the cube. Just this one corner is showing up in the window because I'm really close, or I'm zoomed in. And problem is that if the triangles are to these huge things, then no triangle fits completely on the screen, and if triangles drip off the screen far enough, they become impossible to render. And so you end up with big gaps where it's like this whole section won't be drawn because its triangle is too far off the screen. So you end up with this big black thing that you can't explain. And that was my original reason for wanting to do this. So what happens is I consider 4 points and ask myself, how big would these triangles be on screen? And I have a maximum size, and if they're too big, then I go back to the 4 points and I create 5 new points, the midsection of these 4 edges and the center of the face. So now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 points, but I can subdivide them into 4 squares, where each square now gets 2 triangles. And now I've got twice as many triangles as before, 4 times as many triangles as before, but they're smaller. And as far as do they fit on the screen or not, well, if you're going to have any blackness now, well, maybe the blackness now is only this big. So you've gotten back this area here that you didn't have before. But you can always subdivide it further, get 4 times more as many triangles, but just in this section, because I can stop subdividing as soon as the triangles are big enough. So, great. That's how you subdivide it with a cube. And then for the UV mapping, which is kind of not very exciting, that demo, since it was just a solid purple color, but it was a translucent purple color. That was the cool observation. Actually, I should say that at the top level, before I start recursing into these subsquares, I specifically process the 6 faces separately. So I process the front space, the back space, the left space, the right space, the bottom space, the top space, face. And I can actually, by providing a null material ID, you can tell me, oh, I don't want that face. So if you have some reason to believe that your cube, you're not going to need more than, say, the top and left and the right faces or whatever. You don't have to pass in the rest, and I won't bother to even do any math at all for that. But also, since you can have a different material for each face, you can have the top being different from the sides and the bottom, that kind of thing. You make your classic barrel or whatever. And if you just think in terms of like a Minecraft thing where everything's a cube, then you're done. And you can have a very low resolution. Well, you can have a bitmap rendered on each of these faces. And basically those bitmaps all come from a single texture source, single texture bitmap, but it can be subdivided into little squares and rectangles. And then you can, each of these is a quote material, which can then be applied to any face. And as you subdivide the face up into smaller and smaller triangles, you're also cutting up that material picture into smaller and smaller chunks of the picture so that the picture doesn't change. You just see more of it or less of it kind of detail. Okay, so now what if you wanted a different primitive than a cube? So I still start with a cube, but I pass in a flag saying, oh, but what I really wanted was a sphere. And I provide a center point, which is the physical center of the cube, the center point of the cube, which will also be the center point of the sphere. And from the center point of the cube to the center of any of the 6 surfaces is the same distance, because it was a cube, it wasn't a rectangular prism. And so we're going to call that R for the radius. And there's a fixed radius in each of these guys. So what I do then is when I subdivide, as I subdivide each guy, and I create these new points, which would normally be in the plane of the original faces, and hence flat, making it a cube, which sometimes is what we want. Instead of that, what I do is after I compute the point by virtue of subdividing the square, I compute its distance to the center, which for a sphere must be R. And of course, because I'm a cube, it won't be R. So then I adjust it, making it longer or shorter until it is R. And so what that actually kind of would look more like is, if I was just starting with this side here, I would first subdivide it by coming up with that point, these 5 points. And then let's say these points magically were on R, which they wouldn't be. But this one, I would need to move outwards to here. Now, in the real case, R is in the plane of this, and the guys that aren't in the plane would be pulling inwards. But the point is that when I subdivide this into 4 sections, it looks like this. And when I cut it into triangles, they look like that. And so the net result is it looks slightly more circular. And then if you do that again at every subdivision, every new point you create, you always sphericalize it. You always force the length between it and the center to be the radius of the sphere. Then what you end up with is a sphere. But if you still look at these lines, they look odd, right? It's like they betray the fact that they were a cube, and that the cube was subdivided always in terms of the cube. So you get these sort of non-spherical. It's like your natural assumption would be that you'd be cutting it up into like constant width, longitude and latitude lines. But because you're subdividing the squares in a linear flat space, you don't really get that. So the points are all perfectly placed, but you don't get the evenly distributed points that you might have expected. But so long as you're just looking at a textured thing, you would not probably know the difference. Now that you've seen that, oh, and then for other geometries, for other shapes, I have something I call a radius function. So the radius function for a sphere just returns the r value. But the radius function for some more interesting shape, like say a cone or something really complicated, I can have a function that returns the radius given other information like the face number or the relative xy on the face, on the subdivided face. Okay, so since we're here, let's put on our Cessna, which now is a long press on the stop button, and there's a confirmation, and I say yes, and now I start off with whatever velocity I had, which was 0. So I don't have laminar flow yet, so I don't have lift yet, so I'm just pitching over and starting to crash. But in a moment, my angle of attack will get in range. There we go. Now I can have some control authority, so I can pull back. And let's see if we can land on that runway. So let's give ourselves some flaps. And let's get behind the plane. We'll go this way for a bit. Oh, actually, I know that the runway's north-south, so we'll turn to north. Come on, turn to north. Okay, so now we're headed north. And how are we doing? Let's bring up some more flaps. Okay, and now let's try and get in line with the runway. Hopefully this is enough lead up that we can come in for a landing. Okay, can I see it? Yeah. Oh, it's much closer than I realized. It's right there. Okay, so I need to lose a lot of. Okay, so we go down. Okay, we're lined up pretty well. We're going really fast. Cut our power. Try and lose some altitude and some speed. Okay, well, I lost our speed. Now we need to bring a little power back. Okay. Alright, here we go. Do we have forward velocity? No, we've lost lift. Oh, fuck. Excuse me. Oops. Okay, well that failed. So we landed on the bottom of the ocean here. But the good news is we can just climb that mountain. And here we are. On top of the mountain, right next to the runway. And we just pull up here and then we stop. And here we are, right next to the dome. Right on the runway, right next to the cube. We can't stop. But why would we want to? Let's go to 19% throttle. See what it's like just driving around. So now we're in automobile mode. Turn rate's a little slow. And boat mode will have to follow this. Okay, let's keep our camera synced. Okay. Go check out that cube. No collisions, so we can drive right through it. But the idea is that the starMap basically can drop these primitives as needed to facilitate storytelling. So this is some sort of base that obviously has a runway, and I could be given a challenge to land on that runway. So I need to make sure I can evaluate whether landing was nice. I'm inside the dome, notice. That's cool. So the idea is that dome would be a claim dome, and a player has claimed that region of space, that volume, and it maybe has some defensive capabilities all on its own. Oh, is that smoke? Oh yeah, it's my smoke trail. That's cool. And you can keep critters inside the dome that need a special atmosphere. Oh, that's nice. A little smoke trail spiraling around. There's a car. And I need to do ripples in the water in sort of a similar way, leaving behind just blue/white highlights that spread out from the wake of the water vehicle. Might look halfway convincing from a distance, even though it'll just be triangles. We are crashing down into the water. And I need to make it throw up appropriate colored and behaving. Like that was throwing up mud from the bottom of the ocean when I hit it. And then there should be rooster tails from water getting thrown up when I'm cruising along the top of the water at high speed. So we'll go ahead and take off again. Okay. We're going 88, 90. Should be able to take off about now. Come on, baby. 67 knots. We're probably going to stall out again. Maybe a little more flaps, 30-degree flaps. Yeah, I need to use the same infinite tessellation trick now on the water surface. And then that should help sell the illusion of the water going up and down because of the shared points. And then those shared water points can each have their individual elevation data, their deviation from sea level data. And that should give me the ability to have reasonably nice undulating waves. Just do the same kind of lighting from normal vector that I'm doing here to show the ocean slowly moving up and down. And then when you're close, it might, the smaller triangles might actually be moving more quickly. Might be potentially an adequate illusion of fluid. And then I want to have a meaningful boundary between air and water, but on the other hand, I just love flying straight into it and landing on the ocean bottom. So I don't want to make that impossible. But on the other hand, in many cases, you probably want to crash if an air vehicle hits the ground. But if it's it's the Seaview's flying mini sub, and then it can just dash right back into the water. And, Thunderbirds can go right back in the water. Okay, so that's the runway. It's the runway texture, which is just this huge part of the map, but all it is a black square and a red square. And then this is the texture I'm using on the sphere and the cube. Just, again, I only have one bitmap available to my shader, so my material textures have to come from the same bitmap that I'm using to form the terrain. However, they don't have to be visible areas, and that's just because I'm experimenting still. Although these were surprisingly larger than I expected. Okay, end of film. Thank you so much.